Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 30 to 34 of the Algebra 1 Common Core Regents exam for January 2015. All right, let's take a look at problem 30. It reads, graph the following function on the set of axes below. So we have f of x equals the absolute value of x from -3 to 1, -3 included, and 4 from 1 to 8. Now, one thing you want to note when graphing piecewise defined functions like this, defined in pieces, is that you want to restrict the graphs to their domains, okay? And you also want to pay close attention to what happens on the boundary points and endpoints. Is it open or is it closed? So, for example, we have these two functions here. These intervals to the right of the commas represent the domains. Okay, these are the domains, and you want to pay close attention to them when you're graphing your function. And then concerning endpoints and boundary points, you also want to pay close attention to that also. So in this case, -3 is an endpoint, so you want to look at this inequality. What is it saying? 1 is a boundary point. You want to look at that inequality. What's it saying? And then 8 is an endpoint. What is that inequality saying? All right, so you want to pay attention to a lot of things here. These are the steps we're going to use to graph this piecewise defined function. First of all, we're going to label our two functions and the planes that they will be graphed on. That prevents us from making mistakes with boundaries or plotting the wrong graph in the wrong plane. Okay. After that, after labeling, we will graph our two functions one by one on the same coordinate plane. Okay, so notice this is a nice coordinate plane we've been provided with. All right, so we want to partition. I want to divvy up my coordinate plane into two regions. You see there's a 1 and a 1 here. That's where the break happens. F of x equals absolute value of x goes from -3 to 1, and f of x equals 4 starts from 1 to 8. Okay, so we're going to break at +1. Let's go ahead and draw our boundary point. That's going to be at +1. So this boundary divides my coordinate plane into two regions, region 1 and region 2. Okay, now I'm going to graph the first one on region 1 from -3 to 1, of course, and then my second one will be on region 2 from 1 to 8. Okay, all right, so let's go ahead and label it while we're at it. So this is 0, -1, -2, and -3. Okay, so first one is going to go from -3 to 1, and then the other will go 1, 2, 3, 4, 5, 6, 7, 8, and it stops right there. Okay, now the first graph we're drawing, let's go back to the equation. Remember, we have to label, so this is function 1 and function 2. Okay, all right, so let's go ahead and start with function number 1. So function 1 is f of x equals the absolute value of x. This in and of itself is a piecewise defined function. This is a function that's a combination of two functions to the left or to the right of 0. This function is f of x equals -x when x is less than 0, that's x is to the left, or +x when x is greater than 0. Okay? You can think about this. This is like a v function. So a quick way to draw it is you start from the origin. Let's graph the points. Start from the origin. When you go to the right, you rise 1 and run 1. When you go to the left, you rise 1 and run 1. So if I rise 1 and run 1, there goes my point here. But let's look at the boundary. It's not included. There is no line here, so it's going to be open. Okay? So this would be an open circle right here. And then here you go left. You go rise 1, run 1, rise 1, run 1, and then rise 1, run 1. At 3, it's a closed, you have a line under the inequality, so you have a closed circle. All right? So this is a graph of the first function, the absolute value function. It always looks like a V. Okay, I'm using the shortcut here. So it goes from -3 included all the way to 1 excluded. That's why I have the open circle there. That's very important. Okay, now if you don't remember this trick on how to graph absolute value functions, you can always use a table. Okay, when you're in doubt, you work it out. So let's assume that, oh, we don't remember what this looks like, so we just simply make a table, remembering that our input values go from -3 all the way to +1. Okay, so our x's start from -3 to -2, -1, 0, and 1. This is the domain for function 1. Okay, and we have y is equal to the absolute value of x. That's what our y value is going to be. So when we populate this table, we should end up with the values that are consistent with what we just graphed here. Okay, all right, so let's plug in our input values. Y is going to be the absolute value of -3. Absolute value of -3 is 3. And then absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1. Now, what is the absolute value of 1? Remember, absolute value simply means the distance from 0. How far is 1 from 0? 1. Okay, we're not doing opposites here. That's not what the absolute value function is. Absolute value just calculates the distance of a number from 0. Okay, it is always positive. So if you graph these points, -3, 3, -3, 3 here, perfect. -2, 2, nice. -1 and 1, right here, 0, 0, 1, 1, bam. Okay, so there goes your absolute value function for function number 1. Now, one thing you want to remember, let me just put it right here, is whenever you have less than or greater than, this is always open circle. Okay, so these are open circles. Whenever you have less than or equal to or greater than or equal to, these are closed circles. It could be the boundary point or an endpoint. If the line is underneath the inequality, that means that that value has to be included. Like we had a 3 here, -3, and then a 1 here, we didn't have a line underneath the inequality, so you leave it open. Okay? All right, so we have function 1 on region 1. Now the next function we're going to graph, let me write function 1, y is equal to the absolute value of x. And then the next function we're going to graph, function 2, is very straightforward. F of x equals 4. This is a constant function. Regardless of what x is, y is always 4. But this is going from 1 all the way to 8. But if you look at the inequality, this is closed circle. That means 1 is included in this function. And closed circle here. How do we know? We have the lines underneath the inequalities, all right? So let's go ahead and give ourselves a visual as to what that function looks like. So what we have 1, 2, 3, 4. This function is constantly 4. So when x is 4, y is 4. When x is 2, 4, 4, 4, 4. How far are we going to go? Remember, the domain is from 1 to 8, okay? We had 5, 4 at 6, 4 at 7, and finally 4 at 8. So this is a horizontal function with a slope of 0. Down. There goes your line. Okay. So what are the endpoints going to look? What are the endpoints going to look like here? The endpoints are going to be closed circles. Okay. Let me move this line. Well, good. The endpoints are going to be closed circles because we have the line underneath the inequality. So this is function number 2. Y is equal to 4. Okay. So there goes your graph. All right, let's take a look at number 31. It reads, a gardener is planting 2 types of trees. Type A is tree. Type A is a 3 feet tall Type A is 3 feet tall, sorry, and grows at a rate of 15 inches per year. Type B is 4 feet tall and grows at a rate of 10 inches per year. Algebraically determine exactly how many years it will take for these trees to be the same height. Okay, I'm getting 3 and trees confused. Sorry about that. Okay, now one thing you want to note is that when you're writing verbal growth rate descriptions as provided here in an equation form, the starting value, like the original amounts, the original height, original distance, can always be viewed as the y-intercept. That is when the independent variable is 0. Okay, that's where you're starting from. And the growth rate can be viewed as a slope. Okay, so don't forget that. Secondly, you want to pay close attention to the units when working with models involving units. So here we have feet and inches, feet and inches. So you want to pay real close attention to that. In this problem, we have different different units. So we have to resolve that difference, select the unit we want to work with. Other problems have consistent units across the problem. And then in that case, we don't have any problems, okay? All right, so these are the steps we're going to use. First of all, we're going to write down the slope-intercept form of the equation of a line. Remember, we're dealing with growth rates here, so that's why we're using the slope-intercept form. We're going to find the slope and the y-intercept of the two types of trees using the same units for all our measures, okay? And then secondly, since we're looking for when they have the same height, they have the same y value, we're going to set the two equations equal to each other and solve for that x value that yields equal height, okay? All right, so let's go ahead and start. We're going to start with the first tree, which is type A, okay? Type A. All right, before we do that, I'm not following my instructions. We were to write down the equation, the slope-intercept form of the equation of our line. So let's go ahead and do that first. So the slope-intercept form of the equation of a line is y equals mx plus b. Remember, b is your y-intercept. And what is m? M is your slope. Okay, so this formula or this equation is going to guide our problem solving process. So for type A, I'm going to put y, which represents height of A, is going to be equal to mx plus b. So we need to find the slope of A and the y-intercept for type A. Okay, so for line A, it's 3 feet tall and 15 inches per year. So we start at 3 feet tall. That is your y-intercept, okay? And then 15 inches per year is your slope. So let's go ahead and write that down. So B for type A is 3 feet, and then the growth for type A is, let's put the unit there, is 15 inches. Okay, so the units are different here. We don't want to use different units in the same equation. That's wrong. So which unit can we select? Well, if we want to use feet, then remember we have, let me write this on the side, 12 inches equals 1 feet, or 1 foot, okay? If I wanted to write this, convert both of them to feet, this will be good, but this one I'll have to divide by 12, and it's going to be 5/4, which is a fraction. We could do that, but how about we convert it to inches? If I convert it to inches, this would say 15, and this would be 3 times 12, which is 36, which is much better because we want to avoid fractions if at all possible, okay? So 3 feet is equal to 3 feet times 12, okay? 12 inches per feet, right? So the feet cancel out. 3 times 12 is equal to 36 inches. So please make sure you have the same units before you start plugging stuff into an equation. All right, so for type A, we have y The height of A is equal to the slope, let me write it, of A, x plus B, the y-intercept of A. So we have y is equal to the growth rate, which is 15x, plus the y-intercept in inches, which is 36. Okay? All right, now let's take a look at type B. We want to write the growth rate model for the growth of tree type B in y slope intercept form. Okay, so we just need the M and B. B for B is the y-intercept, initial height, which was, let's go back to the problem. It says 4 feet tall. Okay, that's when you start counting 4 feet tall. So it's 4 feet. And the slope, how fast is it growing every year? It grows at 10 inches per year. Okay, now, am I ready to write my equation in slope-intercept form? The answer is no. Why? Not because the units are inconsistent. So just as we did for type A, we have to convert 4 feet into inches so we can have consistency with our units. So we have 4 feet times how many inches in a foot? 12, right? So 12 inches per foot. Now we just convert this. The feet cancel out. 4 times 12 is 48. So we have 48 inches. Okay, so now we have our slope and y-intercept for tree type B. So we can now write our model. Y, the height of B, is equal to M, which is, well, let's write it. I like to write formulas first before I plug in so I don't make silly mistakes in substitution, okay? So y of B is equal to slope, which is 10x, plus the y-intercept, the y-intercept of tree B, which is 48. Okay, excellent. We're done with step 1, which is generating models for the two cases. Step 2 is we're looking for when the heights are equal. Okay, so when are they going to have the same height? So they have, the trees have the same height when the height of A, y of A is equal to the height of B, y of B. Okay, so what does this mean? We're just simply going to equate these two equations to each other and solve algebraically. Okay, so ya equals yb simply means that 15x plus 36 is equal to 10x plus 48. All right, so let's solve for x. Subtract 10x from both sides. I like all my x's on the left. And subtract 36 from both sides. I want my constants on the right. Okay. All right, so if we go ahead and simplify this, combine them, we're going to have, let's see, 5x, that adds up to 0, equals, this adds up to 0, 48 minus 36 is 12. Lastly, we'll just divide both sides by 5, and that yields x is equal to 12 over 5 years. Okay, 12 over 5 years, or 2.4. Okay, it's the same thing as 2.4 years. Don't forget your units. Okay, so that's that. All right, let's take a look at problem 32. It reads, write an exponential equation for the graph shown below. Okay, so we have a graph of an exponential function. Now, one thing you want to notice is that when selecting points to solve a problem, points from a graph, it's always good to try and use whole numbers, okay? And you also want to make sure that you read your points carefully. Your points have to be the points that are on the line, on the graph, and on the intersection of the vertical and horizontal grid. Okay, please don't pick a point that's not on an intersection that's somewhat close to but not exactly on. That's no good. You're going to get wrong answers. You have to be exact and precise. All right. Okay, so let's go ahead and take a look at the steps we're going to use for this problem. First of all, we're going to find 2 points. That's all we need. We're going to find 2 points that lie on the graph and they're on the intersection of the grids, then we're going to use the equation of an exponential function of the form y equals a times b to the x, and the coordinates that we extract from the 2 points to set up a system of equations. All right, after solving the system, we'll then, just solve the system. After setting it up, we'll solve the system, okay? Okay, now the first task is to select 2 points that are perfect. They have to be on the graph and perfectly lie on the intersection of these horizontal and vertical coordinate grids. What do you think about this point right here, point 2, 1? That's a perfect point. It lies perfectly on 1 and 2, okay? Now, how about this point right here? Is that a good point? No, because it lies on a horizontal grid, but it doesn't lie on a vertical grid. So if we want to predict what this is, it's going to introduce inaccuracies or errors in our solution. You don't want to do that, okay? Let's look for another point that's nice. Oh, take a look at this. We can use 4, 4. This is perfect. Notice this point on the graph. This graph intersects the intersection of the horizontal and vertical coordinate grid. Okay, so we're going to use 2, 1, 2, 1, and 4, 4. Okay, so we have the points. Now, step 2, we're going to write down our equation. The equation that we're using is y equals a times b to the x. So we can use a parenthesis b to the x. Now, we are going to then, let's see, what is our steps? Set up, okay, let's set up the system. So from the first point, point 1, we have 2, 1. So this is x and this is y. So we're going to have 1 equals a times b to the second. Okay. Wait a minute, what just happened here? How did I come up with this equation? Well, you just take the y coordinate and substitute here, and you take the x coordinate and plug it right there. That's how I came up with this equation. Okay. Now let's move on to the second one. The second coordinate is 4, 4. You see what that's going to be? Plug in 4 for the y and 4 for the x. So you have 4 equals a times b to the what? To the 4th power. Okay. Now let's call this, this is our first equation. Let's call this equation 1. And let's call this equation 2. The best way to solve this problem is by substitution, okay? Since a doesn't have any power, that's a perfect candidate. So what I'm going to do is I'm going to isolate a from 1, and I'm going to plug in the value of a from 1 into 2. That will help me solve for b, okay? And then I'll plug in the value of b into any of these to find out what a is. So let me show you what I'm about to do. From the first equation, we have 1 equals ab squared. Now, how do we get a by itself? Well, that's easy. We undo the multiplication of these two by division, divide both sides by b squared, okay? And that implies that a is equal to 1 over b squared. All right? So this, I'm going to call this equation 3. Now, what I'm going to do is, since 3 came from 1, I'm going to substitute it for a in 2. Okay? So substitute 1 over b squared for a in where? Equation 2. That will enable us to solve for b. Okay, let's go ahead and do that. So we're going to have, let's see what's equation 2. That's equation 2 here. So 2, we have 4 equals ab to the 4th. So I'm going to plug in 1 over b squared for a. So this goes right here. Bam. Okay? So that, and now becomes 4 equals 1 over, wait, let me change the color so you don't get confused. 4 equals, so a is no longer a, it's going to be something else, b to the 4th. A is now going to be 1 over b squared. Okay, so this implies that 4 equals b to the fourth over b squared. Now, what is b to the fourth over b squared? You just subtract the exponents, right? Or you write it out, you have 4 b's on top, 2 b's on the bottom. You count the 2 b's on the bottom, takes out 2 b's on the top, right? So this tells us that 4 is equal to b to the 4 minus 2, or you can write it out and cancel. 4 is equal to b squared. What is the last step? How do we get b by itself? What is the opposite of square? You square root, so root both sides, and you have b equals 2. Okay, so that goes our first value. We need to find a, and then remember the problem asks us to write down the equation of the function. Okay, so to find a, we can pick any equation. We can pick 1, 2, or 3, but the quickest one to find a is equation 3, since it's already solved explicitly for a. Okay, so we're going to substitute the b value, 2 for b, where? In 3. That's the easiest one, that's why we picked that one, okay? So we know in 3, 3 is a equals 1 over b squared. So we substitute 2 there, we have 1 over 2 squared there. And then let's simplify that. It's 1 over 4, 4.25. Okay, whichever format you prefer. Okay, so to finish this problem off, let's write down the equation of the exponential function. The equation is y equals a times b to the x. So a is 1/4 or 0.25. Let's use 0.25, and b is 2. So we substitute those values. Here we have y equals a 0.25 times b 2 to the x power. All right, so there you have it. All right, let's take a look at problem number 33. It reads, Jacob and Zachary go to the movie theater and purchase refreshments for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. Zachary spends a total of $27.50 for 4 bags of popcorn and 3 drinks. Write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. Now, one thing you want to note when setting up systems is that it's always a good practice to declare your variables clearly, okay, before using them in your equation. You want to do that to avoid confusion. You want to make sure that you're not interchanging your answers for popcorn with that of drinks, okay? All right, so in this problem, we're going to declare our variables and then use that to set up a system of equations. And it will solve our system of equations by elimination and substitution for the second part. Okay? All right, so let's go ahead and start by declaring our variables. So let's see. Let's call P the unit price. So let P equals the unit price of popcorn. Unit price for popcorn. Notice how I use P for popcorn, right? So I don't get it confused. You can always do that. You don't always have to use X and Y's. And then we have popcorn and drinks. So let D be equal the unit price for drinks. All right. And of course, we don't want to forget the formula. Total cost, either drinks or popcorn, is equal to unit price multiplied by quantity. All right, that's how you calculate total cost. Now, let's start with the case of who are we going with first? Let's start with Jacob. Okay, so deal with Jacob, and then we'll deal with Zachary after that. Jacob. All right, so for Jacob, let's look at the price of, what should we do first? We could do popcorn first. So total cost for popcorn is called a TCP, is going to be the unit price of popcorn times the quantity. Okay, so the unit price, so unit price of popcorn multiplied by how much popcorn he bought. Okay, all right, so if you look at the problem, Jacob bought 2 bags of popcorn and the unit price of popcorn is P. So total cost for popcorn for Jacob's case is P times the quantity, which is 2. You can write it as 2P. Okay, this is the standard way of writing it. All right, how about a total cost for drinks for Jacob? The same idea, unit price of, let's write it down, unit price. That was the price of 1 drink, okay? Unit price of drinks times how many drinks he bought, all right? So if you look at the problem, he bought 3 drinks, okay? So P times 3, oh, I'm sorry, it's not P, it's D. Unit price for drinks is D, so D times 3, which is 3D. Okay, so now what's the grand total for Jacob? Jacob has a total of $18.25. So the final total cost for Jacob is going to be 2P as the price of popcorn, total cost for popcorn, plus 3D total cost for drinks. But we also know that the total cost for Jacob is $18.25. So we can write the equation 2P plus 3D is equal to 18.25, right? Since the total cost, the total amount of money that Jacob spent is equal to 18.25. All right, so that's basically how you set up an equation. All right, so we're going to go into Zachary's case, but before we do that, let me box our final result. All right, so for Zachary's case, let's go over his cost. All these steps I'm doing are not necessary. I'm just trying to show you exactly what the process is, so you can skip all of this to the final equation if you know how to do it. All right, so for Zachary's case, the total cost for let's do popcorn first. We already know what the formula is, so it's going to be the unit price of popcorn, which is P, times the total number of popcorn he bought. How many popcorn did Zachary buy? He bought 4 bags. Okay, so you can write it as 4P. And then the total cost for drinks for Zachary is the unit price for drinks, D, times the total number of drinks he bought. He bought 2 drinks. Okay, so the total cost for drinks is 2D. You notice I skipped some steps, but that's fine. All right, so the total cost for Zachary altogether is the sum of these two, right? Total cost for popcorn 4P plus total cost of drinks 2D. But we know that Zachary spends a total of $27.50. So 4P plus 2D has to be equal to $27.50. Okay? Since the total amount of money that Zachary spent is $27.50. Now we have our 2 equations to formulate our system. We'll just simply put them next to each other and we're done with the first part, okay? So our system of equations, let's write it down. System of equations is 2P plus 3D is equal to 18.25, and 4P plus 2D is equal to 27.50. All right, so the B part says, using these equations, determine and state the price of a bag of popcorn and the price of a drink. So we're looking for the unit price. We're to find P and D. All right, so that's what we're going to do. We can do this by elimination. So what we're going to do, let's eliminate the one that's easiest to create opposites for, okay? So you notice there's a 4 here. Can I multiply this equation by a number that easily helps me find out that easily converts this to a 4? Yeah, I can multiply by 2, okay? So let's call this equation 1 and call this equation 2. What I'll do now is multiply the first equation by -2 because I want the coefficient of P in equation 1 to be the opposite of the coefficient of P in equation 2. So when I combine these two linearly, they cancel out and I can figure out what D is. So please do not forget to distribute this -2 to all the terms in the equation number 1. And we carry out that distribution, we're going to have -4P minus 6D is equal to -36.50. Bring down equation 2, 4P plus 2D equals 27.50. And then we just combine, okay? Since we have opposites with the P, they should add up to 0. They drop off, which is nice. And then we have -4D is equal to 9, actually -9.0. All right. So to get D isolated, you divide both sides by -4. And that yields D equals 4 goes into 9 2 times, remainder 1, 2 1/4. In dollars and cents is $2.25. Okay, so that's the unit price of D for drinks. Perfect. Now let's go ahead and find the unit price for popcorn. Okay, so let's find P. Now, how do we find P? We can just plug in this answer that we got into any of these equations. Okay, so what I'm going to do is I'm going to substitute 2.25 for D, and how about we use equation 1? All right, so if I do that, I'm going to have 2P plus 3 what? Instead of D, I'm going to put in the answer for D, which is 2.25 equals 18.25. And then just solve this equation for D and for P, and we'll be done. All right. So we have 2P plus 2.25 times 3 is 7.10. No, it's 6.75. 6.75. I don't know where that came from. Okay, so 6.75 equals 18.25. So let's get P by itself. First thing to do is subtract 6.75 from both sides. And that yields 2P equals, we subtract, you can just use your calculator, all right? Subtract 6.75 from 18.75, you have 11.5. Divide both sides by 2. And you can do this in your calculator, you get P equals 5.75. All right? So we want to contextualize our solutions. What on earth does this mean? Don't just write it like this and expect full credit. You want to make sure that you explain what your answer means. Okay, so the unit price, or price of a drink, unit price of drinks is $2.25, and unit price for popcorn is what? It's $5.75, okay? So that's that. All right, let's take a look at number 34, the last problem in this installment. It says the graph of an inequality is shown below. Write the inequality represented by the graph. All right, so that's the first part. Of course, there's a B part. So one thing you want to note is that when generating linear inequalities from graphs, you want to pay close attention to the line style. Line style, is it solid or is it broken, okay? And then also you want to pay close attention to the direction of the shading. Is it above the line or is it below the line? Okay, because that impacts um, the inequality symbol. All right, so these are the steps we're going to use. First of all, we're going to write down the slope-intercept form of the equation of the inequality. We're going to find the slope and the y-intercept. And just substitute and that'll be that, okay? So first of all, the slope-intercept form of this particular inequality. Now, one thing you want to note is that the line style is solid, okay? And the shading is above. So what does this mean? If you have a solid line and shading is above, the equation in slope-intercept form is going to be y is greater. Remember, shading above is greater, shading below is less. Is greater than mx plus b. Now, since it's solid, guess what? You have to add that inclusion bar at the bottom of your inequality symbol, okay? So it's greater than or equal to. Now, if this line were broken, guess what? We'll take out this piece. Just make it be greater, okay? So don't forget, shading on top, think about this as a roof. Shading on top is greater, shading on the bottom is less. Colored line, you have this line here. Broken line, you don't have that there, all right? Okay, so let's go ahead and set this up. Looking at the graph, we can find out what M and B are. B is the y-intercept, 1, 2, 3, negative 3. So this is where the graph intersects the y-axis. So B is negative 3. What else do we need? We need M. M is a slope, rise over run. Let's pick up another perfect point. Oh, wow, this point is great. You rise 1, 2, so rise 2, and you run 1. So what is your slope? Remember, your slope is rise over run. So in this case, it's rise of 2, run of 1. Our slope is 2. Okay? So can we write down the inequality for this line? Absolutely. It's going to be y is greater than or equal to m, which is 2x plus b. So it's plus negative 2, negative 3. Don't forget the sign, okay? Don't leave that out. So we simplify it, resolve these two signs, minus times plus. Anytime you multiply different signs, you always have negative. So y is greater than or equal to 2x minus 3. That is the inequality for this graph right here. All right, let's take a look at the B part. It reads, on the same set of axes, graph the inequality x plus 2y is less than 4. Okay, so one thing you want to note is that when graphing linear inequalities, it's much safer to place the inequality in slope-intercept form first. Okay, that helps you avoid errors concerning the orientation of your shading, okay? So that's very important. So these are the steps we're going to use. First of all, we're going to write the slope-intercept form of the equation. Slope-intercept form of the inequality. And then we're going to find the slope and the y-intercept, the line style, and the shading. And then use that information to graph this inequality on the same coordinates system. There's a reason why they want us to graph it on the same coordinate plane, because we're going to be using that for part C. Okay, all right, so let's go ahead and get started. So we have x plus 2y is less than 4. So I want to get y by itself. That's the goal. Okay, so to accomplish that, we'll simply subtract x from both sides. Subtract x, subtract x. That yields 2y as less than negative x plus 4. And then now we'll divide every single term by 2. Okay, divide by 2, divide by 2, divide by 2. That will result in the isolation of y. All right, so if we do that, we're going to have y is less than negative 1 over 2x plus 4 over 2 is 2. Okay, now, what is the slope? Let's write down our guide, which is y is less than mx plus b. B is there's a number you add on to this term here. M is a coefficient of x. So in this problem, M is negative 1 over 2. That means that we're going to rise negative 1. What on earth is negative 1 rise mean? It means you're going to go down 1 unit. That's a negative rise. And you're going to run 2. You always run to the right. Okay, so we're going to go to the right 2 units. So that's our directions, but we need a starting point. Where do we begin from? That's your B, your y-intercept. Your beginning B is 2. Okay, so we're going to start at 2. So the question is, what effects are there going to be on our line and our shading? Remember that, let me show you something real quick. Let's say you have less than or equal to, greater than or equal to. Okay, so how can we organize these inequalities in a way that helps us remember? So the ones on top, basically these two, if you think about the shading, I mean the line style, these are broken. Why are they broken? Because they don't have line on the bottom. Okay, and then for these two, because of the line underneath the inequality, the line style will be solid. All right. Now, how about the shading? The shading. Let's talk about that. So for the shading, this one right here, the left column, since it's less than, you're going to shade below. Shade below. Okay, below the line. And then these two greater than, you shade above. Shade above. So this is basically your guide for determining your line style and direction of shading. This has less than, so what does this less than mean? It means that it's going to be broken. And where do you shade? And we're going to shade down beneath the line, depending on the orientation. All right, perfect. So let's go ahead and graph the line. The inequality on the region provided. So always begin with the B, the y-intercept. In this problem, our y-intercept is 2. So B is 2, 1, 2. We're going to rise negative 1, go down 1. So rise negative 1 and run 2, 1, 2. So there goes our second point. All right, let's go ahead and graph the line. Remember, our line style is broken or dotted, whichever way you want to call it. So dotted line through these 2 points right here. Okay. Next effect we're going to apply to our solution, or not solution, sorry. So our graph is the shading. Where are we shading here? Remember, less than means you are shading below. Okay, so we're going to shade below. So if we graph that, we have this region right here. Shade, 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 shade below. Okay, so there goes the graph of the second inequality. All right, let's take a look at the C part. It says the two inequalities graphed on a set of axes form a system. Oscar thinks that the point 2, 1 is in the solution set of this system of inequalities. Determine whether you agree with Oscar. Explain your reasoning. Okay, so what is the solution of this system? Well, the solution of this system is the collection of points that lie in this shaded region right here. Any points that lie in this shaded region is in the system, is a solution. If it lies in this region, let me erase this one. This is not a solution. It's not a solution. Okay. Now, how about boundary points? Any point that's in this shaded region on this line or on this line is a solution. Okay? But any points that's on this line cannot be included. Why is that? Well, it's because the line is broken. All right, so technically, this point here should be an open circle. All right, so any point that's in this region, this half space, or on this line, excluding this point, is a solution. Okay, so in this problem, Oscar thought that this point right here, 2, 1, is in the solution region. What is your answer? Is he correct or wrong? Do you agree or disagree? Since this point lies on the line that's excluded from the solution region, then it is not a solution. It is not in the solution set. Okay? So let's go ahead and write down our answer and why. Um, do you disagree? We disagree. Disagree with Oscar. Why is that? Because 2, 1 falls on the broken line, a collection of points that are not in the solution set. That's why the line is broken. Okay, so any point that falls on the broken line, that point must be excluded. It's just like an open circle in a linear inequality, in a number line. Okay, so that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this presentation beneficial, do give us a thumbs up. We'll appreciate the positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about the Algebra 1 Common Core Regents exam for any year or need any kind of support, just place your question or concern in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on mathgotserved.com/testprep. Thanks again for watching, and have a wonderful day.